Hi everyone, my name is Laura Hyatt. Thank you so much for attending this talk. I'm a solutions architect here at AWS. I look after our education customers in the UK, so that is, universities, researchers, and edtechs. IoT is one of my favourite areas of AWS, and was actually one of the first that I ever one of the first services that I ever actually used. So today's talk, I'm going to walk you through a rather fun, if not silly, AWS IoT demo that I built. Just kind of show you some of the capabilities of AWS IoT. And to be honest, the reason for this is because it's quite a hearted talk, and I think that learning should be fun. So, before we get started, and I know this is obviously an IoT community day, but I just always like to start with the definition of what IoT is, just so we're all kind of on the same page, really. So, in the broadest sense of the term, IoT encompasses everything that is connected to the internet. But it's also been increasingly used to define objects that talk to one another. So simply that the Internet of Things is made up of devices, from simple sensors to smartphones and wearables that are connected together via the internet. And it's really by combining these devices with automated systems that make it possible to gather information, analyze it, and create an action. And it's this that makes IoT really, really powerful. So, now that we have that sort of common understanding, what is IoT being used for? I think, most of us are familiar with smart homes, and then that's where sort of the general public's understanding of IoT comes from. But actually, IoT is being used across industry-wide. In AWS, we're seeing it across the board of our customers, from manufacturing with predictive maintenance to healthcare with, remotely monitoring patients' health. And then also my sector, so education, we're seeing, smart campuses, and especially now, due to sort of COVID times, we're seeing, remote learning being used and tools that offer help with that. However, not all IoT is good. I guess with anything, there are fads and trends, and IoT has definitely not escaped that. I really love this graphic. It just kind of shows you how overboard you can really go with IoT, and I definitely think smart homes is one of the areas that that can go a bit overboard. For example, I have a washing machine that you can connect to the internet, so you can remotely monitor your status of your washing, I guess. And I mean, why? I don't like washing that much. However, speaking of the internet of useless things, I wanted to introduce you to my sentiment analysis sweep machine. Basically, what this is an emotion detecting sweep machine. So what it does is it uses a camera and image recognition to detect the emotion on your face, and depending on the emotion, you get different types of sweets. Now, I built this for a tech conference. So in education, there's this sort of big yearly educational technology conference called UCISA. It was going to be happening in, I think it was February or March. Time seems to definitely be a different thing during COVID. Obviously, the conference never happened, but AWS was sponsoring it, and it's one of those conferences that is booths, with different vendors showing different wares, I suppose, a bit like the summits. And we had a booth, and we were trying to think of different demos that we could show sort of AWS capabilities and get people to come over to the stand. And obviously everybody loves swag, but then what we kind of find is that people want the swag but don't actually want to engage in a conversation about AWS. And so I was trying to think of something I could do, and talking of swag, everybody loves sweets. And so I was like, can I do an IoT AWS sweet machine that gives you sweets, pick and mix? And that's kind of how it was born, really. So let's have a look at the actual video, just to give you an idea. This is very much a prototype, so it's always a bit messy. This video was quickly filmed by my friend sort of at the end of the day, but it gives an example of what it is. So, okay, hopefully you got a sense of how that works. So let's have a look at the architecture of this thing. So it's actually very simple. I think that surprises a lot of people. It really only comprises of a few different services. So how it works is, I used a Raspberry Pi with AWS Greengrass running on it, and then I had a big red button and a Pi camera. So for anyone who's familiar with Raspberry Pis, just the Pi camera module. And then basically you push the button, and basically this triggers just a really simple Python script that triggers the camera to take a photo, and then send this photo to S3. And then once a new object is in S3, once it hits that bucket, it then triggers a Lambda function, which then in that Lambda function, again, I'm just writing it in Python because that's my language of choice, basically calls recognition, which is basically image recognition service, and it performs facial recognition on the photo just taken. And with the facial recognition API, one of the different attributes you can get is the emotion, or as I call it, sentiment of the face that you've just taken a photo of. And then basically in my code I did some I guess filtering of the different attributes we received and the different emotions, and basically the highest emotion, or the most confident emotion it found, then triggers a different GPIO pin on the Raspberry Pi, which is connected to the motor of different machines. So I've got 3 different sweet machines. I called one the happy sweet machine, one the sad sweet machine, and one the angry sweet machine, just because I thought they were the sort of most different of sort of facial sort of expressions people would pull. And then depending on which emotion it detected, it would trigger a different GPIO pin connected to a different sweet machine and give you those sweets. So if you're happy, you get happy sweets. If you're sad, you get sad sweets. And if you're angry, you get angry sweets. And that's the simplicity of this demo. So let's take a closer look at some of those services that make this architecture work. So there's lots of different IoT services in the IoT stack. I'm obviously not going to go into these today, but there are different IoT software that help you connect to AWS depending on what your hardware architecture is. So obviously there's microcontrollers and microprocessors. In my case, I used a Raspberry Pi, so a microprocessor. I could have used a microcontroller because it is just one sort of action that is being done. You could really architect this in many different ways. I'm just much more familiar with Raspberry Pis. I had one lying around at home as well, so I just chose to use that. But if you're more of a microcontroller person, maybe an Arduino or something, you can use that. So for microcontrollers, there's the FreeRTOS software, which is basically an open source real-time operating system for microcontrollers. This is not an AWS service, but we have Amazon FreeRTOS, and it's a free service. We're not charging you for this open source software, but with it comes additional packages to help you connect to AWS. With Greengrass, Greengrass extends AWS to edge devices, and so that you can act locally on the I can't even speak. So you can act locally on the data that you generate, and then still use the cloud for sort of analytics management or durable storage. So I chose Greengrass to run on my Raspberry Pi. So, for anyone who's not familiar with Greengrass, let's take a look at it. Greengrass is actually one of my favourite services from AWS. It's actually one of the first I sort of ever really used, actually, when I was kind of learning about AWS many years ago. So, like I said, Greengrass extends AWS to your devices, so you can act locally on the data you generate. So, what it is with Greengrass is that you don't have to send your data to the cloud immediately. And so this can save you time, because of latency issues, it can save you time when processing that data. And so there might be use cases where, you don't have an internet or stable internet connection, or latency is really, really important, or you want to lower your costs. These are some of the great sort of benefits of Greengrass. Obviously, in my case, it wasn't as much. I just chose Greengrass because it's a really nice service to use for this, but there's lots of additional benefits that obviously I didn't, need for my use case, but just to kind of explain some of Greengrass's additional benefits. Also, for example, you might have sort of a need for the data to stay in the place that it's generated. So in the case of data sovereignty, so obviously we have regions across the globe. We don't have a region in every single country. And we find actually, especially in public sector, so where I sit, we find some customers have data sovereignty sort of requirements. And so actually you can store and do analytics and sort of process data locally on your device with Greengrass. And so that can actually be a real benefit to a lot of public sector customers. So that's kind of some of the benefits of Greengrass. Obviously, I didn't need all of those, but it's just a really, really good service. And the way this works, and I'm going to sort of explain some of the sort of the use cases of Greengrass, is because actually Greengrass, you run Lambda functions, so our sort of serverless compute service. You can run Lambda functions locally on your Pi, so you don't have to have that connection to the cloud constantly. And this is actually really great if you want to trigger GPIO pins. And so that's the reason why I chose to use Greengrass in this case. So some of the reasons you might want to use Greengrass outside of Sweet Machines is, yes, you can sort of remotely control and trigger devices because Lambda function does run locally on that device. But also another great thing about Greengrass is that you can actually do machine learning inference at the edge. This is actually sort of an additional feature that came about sort of because of what customers were asking us. So if you think about it, the cloud is perfect for machine learning training models because it requires, a substantial amount of compute power. However, there might actually be a need to run these models locally on a device. Say you had a camera and you were training to detect, people who were allowed or not allowed in a building. And so you train that model in the cloud, but then you might want to deploy it locally on a compatible camera so that it can then detect the faces of the people that are coming. I don't know if it's to sort of the entrance of a building, and then it can be like, yes or no, this person's allowed to be in the building, trigger the door lock, whatever it is. And then that data, as it collects, can then be sent back to the cloud and back to the model to retrain it. And so actually there's sometimes a need for machine learning to be run at the edge. And this is a really great example of why Greengrass. And then, of course, there's also the sort of streaming of data. So Greengrass, you can collect and process and export data streams from IoT devices. And actually, you don't have to have a constant stream. With Greengrass, it will keep data in sync even if you're not connected to the cloud. So with IoT devices, because of the nature of them, they might be out in the field somewhere. In a factory, you might not have a constant or great internet connection. And so actually with Greengrass, it will store the data and then sync it back up when you get a connection. So now that we kind of got a bit about Greengrass, let's talk about image recognition. Because it's kind of really the sort of, I guess, the key component of my Sweet Machine. Now, AWS has many different services for machine learning, but one of the great things about AWS is that you don't have to be a data scientist. I'm not a data scientist and have no machine learning background, but I can still use some of the machine learning services because, for example, Amazon Recognition, it is abstracted sort of a layer above, and all it is you're required to write some code. And really the idea of this is putting machine learning in the hands of every developer. So let's talk about Amazon Recognition. It's actually one of these services that I only started using, I think it was about December last year. I started to use it and really, really like it. I think it's awesome. So basically, Amazon Recognition has been going for about 4 years now. I think it was 2016 that we launched it. And there's many different features within it. And actually you can do image recognition, but also video analysis as well with recognition. And basically it's using pre-built machine learning models that have already been built and trained that you don't have access to. All you do is basically use simple API calls to get the sort of analysis that you require. And as you can kind of see from the slide, there are many different bits of analysis that you can do. So from doing scene detection and object detection, to doing text in an image, to doing also unsafe images, so like image moderation, and then also face detection and analysis, which is what I used. So how does this work? What does it look like? So over on the left is the JSON for the image that you want to do facial analysis on. So using the detect face API call, basically takes the source image from the S3 bucket, and then over on the right is the analysis, and this is the JSON that it returns. So when you provide an image that has a face, it analyzes the facial attributes of that face, and then basically returns. There's a number of attributes that it returns and a confidence score. So there are things like age, gender, but the one that I was interested in was emotion, or as I called it in my title, sentiment, but strictly speaking, it's emotion. And then what it does is it gives you the emotion that is detected and a confidence score. Now, it will give you all the emotions that has been detected in that image, and usually it won't just be one. So it might be happy 80%, calm 18%, and unknown 2%. And so all I did was do some sort of sorting and filtering in my code to only return the highest confidence score. There are 9 different emotions it can detect. I only used 3 different machines, so I did group emotions together. So I had 3 categories, happy, sad, and angry, just because I thought these would give the most sort of devices, the most diverse facial expressions when people were sort of playing with this. And then basically I sort of, grouped together. So if someone was, so for the angry one, if it detected that fear was the strongest emotion, then I just put that in the angry category. And then basically, based on those sort of 3, whichever was the strongest, it would then trigger a different GPIO pin on the Raspberry Pi, which would trigger the sort of the motor of the sweet machine. So really, that's as simple as it gets. As you can see, it's a relatively simple. Recognition's a relatively simple service, actually. If you're a developer or know how to code, it's a really simple service to use and can add a lot of benefit to your applications. So just before I kind of wrap up this, I wanted to show you another demo that I'd done using recognition and IoT. Again, another fun sort of demo. I promise you I do more serious things for my actual customers. But basically, I don't have a video of this. I really should film a video at some point. But last year I did a sort of proof of concept for It was for a smart car park that could be used in educational, like university car park essentially, but could be any car park really. And I was doing number plate recognition, and it was using the text detect API to determine if that car was allowed in the car park. So it was a very similar setup actually of how I kind of got the idea for the sweep machine. This one actually came first. I did this about December last year, and the sweep machine was about February. So what it is I had a camera, a Raspberry Pi camera again. I actually had an ultrasonic sensor that basically when the car, and as you can see it's using Lego, always good for a demo. So when the Lego car came up and passed the ultrasonic sensor, it would then trigger the Raspberry Pi camera to take a photo. And so instead of the button, like the sweep machine, this was an ultrasonic sensor, the camera would take a photo of the number plate, send to S3, and it would get the text of the number plate. And then what I was actually doing with this was then comparing it to DynamoDB. So compare it to the entries in DynamoDB to see if that car was allowed in the car park. So it was like a permit car park, permit holder car park essentially. So I was comparing if there was a match, then a little servo and it would open a barrier and they were allowed in the car park. If no match, they were not allowed in the car park. So it's kind of like I sort of made my own ANPR really, but you can kind of see kind of some of the use cases. And just to kind of, just to show you, this was obviously text in the image was the API that I used for this car park. So there's lots of different sort of uses that you could use for recognition. These are just two of them. So I hope you found that really, really interesting. It's just a bit of fun, I guess, to show you how you can use AWS IoT and some of these sort of like complementary services. So in this case, recognition, which is just an API call machine learning service. If you do want to find out any more information, I've just put some links there. I'm not sure if you can click them or if they'll just be made available in the chat. But basically these are the services that I used, and there's also a training video there on IoT. It's all free, so just if you want to kind of learn more about them. Of course, if you've got any questions for me after the session, obviously ask some questions now, I've got some time. But if you want to ask any questions, here's my email address. Feel free to drop me a message about any use case you have. And also I'm quite active on Twitter, so if you have any comments or if you did enjoy this presentation and want to tweet me, here's my handle. So I hope you enjoyed that, and thank you so much for joining, and thank you.